Hello friends, welcome back to our channel. So in our previous session we have discussed about the greedy method application, that is single source shortest path, and now we'll see an example for single source shortest path. So we can also call it as dijkstra algorithm, and example for this dijkstra algorithm example, right? So before going to the example, let us recall the algorithm. Okay, so first we have to select the source node or a source vertex, and we have to give the cost of that particular vertex as 0 and cost of all other vertices with an infinity. That's the first step. Second step, among all the cost or the cost of all vertices, select the minimum cost vertex. Okay, so that will be a visited vertex, right? And from that we have to change or update the cost of neighboring nodes, unvisited neighboring vertices, and we have to repeat the same process until all the vertices becomes visited vertices. So the main aim of this particular algorithm is to find the shortest path from source to all other vertices, not from source to destination, source to all other vertices, right? Now we'll see an example. So let us take an example: A, B, C, so again I am taking undirected graph. Okay, so I'll give you some weights, random weights. I am giving some random weights. So let us take it as 8. Sorry. Okay, so this is a graph. Okay, so finally we'll get some tree. Okay, so from source, so I'll consider this one as a source. That means A is a source. So first what we have to do, we have to give the cost for every vertex. Okay, so I'll update the cost for A as 0 and all other vertices with infinity. Okay, the cost of all other vertices as infinity, right? Now we have to find out the minimum. Okay, so the first step, cost of source 0, cost of other vertices infinity. Second step, minimum of all cost. Okay, the vertex, select the vertex with minimum cost. I'll write completely. Select vertex with minimum cost. So what is the minimum cost? A, right? A. So select this one. Okay, and now we have to update the cost of adjacent. So let us select A. Okay, so let us select A. So what are the adjacents? B and F. So update the cost of B and F. So this is a direct edge. Okay, so we can update with a 5, and here it is 7. Okay, 5 and 7, all remaining are infinity, and mark this one as a visited node. So A is visited now because from A we have find out all the cost of adjacent vertices. Okay, so we only two neighbors, so we found the cost of these two neighbors, B and F. Now we need to find the cost of, so the second step, we have to repeat the second step. What is the second step? Select the vertex with minimum cost. So I'll update here visited. So A is visited, and next upon all these things 5, 7, infinity, infinity, infinity. So among this one, which one is the highest? Sorry, minimum 5. So select B. Select B. Now find out the neighbors. Okay, what are the neighbors? One is A, another one is F, another one is C. And you can observe A is already visited. You can see A is already visited, so you need not bother about A. So we need to find the cost of neighbors, unvisited neighbors, F and C. Okay, F and C. So what is the C? Update. So 5 is a cost. Here source is A, right? So the name itself indicates it's a single source shortest path. So we need to find out the shortest path from the same source. From A to B it is 5, and from B to C 5 plus 6 it will be 11. So the path from A to C via B will be the 11, and we have updated it. Now we need to find out the F. Okay, F. So from B to F it will be 5 plus 8. Okay, so don't forget to count the actual cost plus the weight, because here the source is fixed. That means we are finding the path from A itself. So here B to F means A to B and F. So this implies A to B, B to F, A to C, sorry, A to B, B to C. Okay, so A is visited and we are finding the next minimum path. So B to C it was 11, and B to F, what happens? 5 plus 8. Okay, so for this one it will be 5 plus 8, which gives 13. So we need to find the existing cost and the calculated cost, and we need to select the minimum among that one. So here already F is visited with a 7. Okay, there is the shortest path from A, it is 7, and now through B it will be 13. See, A to F is 7, and A to B and to F it will be 13. So among this one, which will be the shortest path? Obviously this will be the shortest path. So we need to select the minimum. Okay, minimum. So we need not update this one. We need not update this one. So we have already done with the neighbors of B. We have already done with the neighbors of B. So we can add this B to the visited set. So this node is visited. Now repeat the same process. Select the vertex with the minimum cost. So here vertex means unvisited. So here unvisited are F, C, D, E. Among all these one, which is the shortest? Minimum cost. Here 7, it is 11, infinity. So F is the shortest one. Minimum cost. So we can select F now. And now find out the adjacent neighbors of F. F, A, B, E. And you can see A and B are in the visited. So simply you can ignore. Okay, we need not revisit that particular vertexes. Okay, only there is a path from F to E. So the cost is 3. But here this implies what is this one? A to F and F to E. So what is a to F? It is 7. The cost plus 3, 10. In order to reach from A to E, the cost will be 10. So this is a 7 and this is 3, which gives 10. Right? So update this cost 10. Okay, so any other neighboring vertex, neighboring edges? No. So obviously we can add this to F. Okay, and this is the visited. F is visited now. Now repeat the same process again from the unvisited nodes or unvisited vertices. Select the minimum. So which one is having the minimum? E with 10, C with 11, and D with infinity. Obviously E is the minimum. So E, and find out all the adjacent or the edges, neighboring edges. So E to F, E to C, E to D. Okay, E to F, E to C, E to D. Not this implies A to F, F to E. So we can write it here. A to F, F to E, and now E to F or E to C or E to D. So here any vertex in the visited, yes, F is already visited. So you need not worry about this one, F. So we have to find out the cost for E to C and E to D. So E to C, see, E to C. E to C means, see, A to F, F to E, E to C. Similarly, A to F, F to E, E to D. So what is the cost here? So A to F is 7, 7 plus 3, 10. So here we got a 10. So simply we can say 10 plus C, 10. See, E to C it is 10. So total 20. Already the cost of C from A is 11. That means the path or the distance required for A to reach C is 11 through B. And the path from A to C through F and E becomes 20. So which one will be the lowest? So obviously 11 will be the lowest. So we can discard. So we have to select the minimum. Okay. Now coming to this one, E to D. E to D. So already 10 is the cost to reach up to E, and to D it will be 12. So update this with 12. 12. So this will be 10 plus 2, it will be 12. And 12 and existing is infinity. So 12 and infinity, the minimum will be 12. So we are updating here. And what happens? Any other edges? No. So obviously we can select E as a visited. E as a visited. And here it will be E. Again, we are having a two more unvisited vertices. That is C and D. Select the minimum cost vertex. So among the C and D, C is the minimum. C is the minimum. So what we have to do? So we need to select C. In order to get C, we are using A to B, B to C. So what are the adjacent? C to B, C to E, C to D. And this comes from B and it comes from E. This implies. So we are just having the path from C to B, C to E and C to D. Select, verify whether any vertex are in the visited. So B is visited, so you need not worry about this. E is also visited, you need not worry about this. So we are having only one edge, that is from C to D. So that implies A to B, B to C, C to D. So up to C it is 11 plus C to D it is 4. So which is 15. So from A to reach D, the cost is 15 through C. But through E, it becomes 12. So among these 12 and 15, which is the lowest? 12. So we can discard. So any other edges? No. So simply you can add it to visited. So you can add it to the visited. And now repeat the same process. Consider all the unvisited vertex, and from that unvisited vertex find out the vertex with the minimum cost. So we are having only one unvisited, right? Only one unvisited. So only one, and rest of all are visited. So obviously this will be visited with a 12. So this will also be added in the visited set. So this is the procedure to find out the minimum cost for each and every vertex from the source vertex. So first source is A. So B, C, D, E, F are the different vertices. So we are finding the shortest path to reach all other vertices from the source vertex. Okay, so what is the shortest path? Let us take A to B, that is directly it is a 5, and A to F, it is directly a 7. So what about C? So A to B, B to C, it is 11. Next, E, A to F, F to E, it becomes 10. Next, A to F, F to E, E to D, it is 12. So this is the cost from A to B, A to F, A to C, A to E and A to D. So you can apply here. First step A, so it is a visited, and after that B. Next it becomes a B. Next it is F. Next visited is E. Next visited is C. Next visited is D through E. So this becomes a tree. This is not a graph, because we know that graph is a connected, right? So closed graph, closed loop. So here it is not connected, right? This is a tree, minimum cost tree from the single source. So this is a source. This one will be the source. Okay, so hope you understood this one. So the problem is finding the source node and finding the shortest path from source to all other vertex. Okay, so here I am not talking about the destination. So we are not considering the destination as D and finding the cost to reach the destination. So here the question is finding the shortest path from source to all other nodes. Okay, right? So this is the procedure, and what is the time complexity of this one? What is the time complexity? So one point is finding all the vertices. Okay, so considering all the vertices from A, all the edges. So what we are doing here is, so we are selecting A and all vertices, edges B and F. Next we are getting B and all vertices A, C and F, and we are finding the C with B, E, D and E, and D with C and E, and E is having some C, F and D, and similarly F is having A, B, E. So we are selecting each and every vertex and finding the edges, the cost of all incoming or outgoing edges. Okay, so that implies in order to iterate each and every vertex, it will be n minus 1, and again we have to repeat all the edges. So the maximum edges we can get is n minus 1, right? If n vertices are there, it can have n minus 1, right? So n minus 1 edges. So it will be n square. So the time complexity is order of n square. Order of n square for this particular dijkstra. And this is an example application of greedy method, which is used to solve the optimization problems. So here you can observe, in order to reach C, it can go with A, B and C, also A, F, E and C. And in order to reach F, it can directly go with a direct edge, or it can reach till A, B and F through B, right? So for this kind of problem, we are having a multiple solutions. So here, in order to reach F, what we are doing? In order to reach F, A to F is one path, A to B to F is another path. So we are having a multiple paths, and again we can have a multiple A to B, B to C, C to E, and E to F. So that's also one path. So that means for finding the cost or reaching this one, so we are getting a lot of paths, multiple paths. But what we are selecting the path with minimum cost. That means the shortest path. So that kind of problems we call it as a greedy method, and this particular algorithm is implemented or solved by using this greedy method, selecting the optimal solution from a solution set. Right? So let's stop here. Hope you understood this complete procedure. So if you want to know the procedure step by step, so visit the previous video. In that previous video, I have explained the complete step by step with a simple example. And here in today's session, we have seen one example along with this, finding the final complexity, type complexity. Right? So let's stop here. If you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you are really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.